Alright, so in this video we go over section 2.4, linear inequalities and problem solving. So here we're going to review a little bit of interval notation and their use and solve linear inequalities. So first of all, let's get used to using interval notation. Okay, so the following examples, we're given a mathematical expression expressed in set builder notation. And this represents a set of numbers. They're asking us to graph the solution set and write that in interval notation. Alright, so here in this case we need to know how to read this expression. So let me use a different color for that purpose. We use green, so this means the set of all real numbers less than -2. Okay, so like other not like which numbers, like -3, -4, -5, etc. All right, so what are we going to do in this case? Well, so we're going to go to -2, which is right here. And well, there's two different ways to express this one. Okay, I'm going to do, well, let me locate the number -2. And in this case, well, in which sense or in which direction are we going to shade this? Well, think of this inequality as telling us about the direction of an arrow. So if you draw an imaginary arrow, we are going to shade towards the left. So that means we're going to go all the way to the left of -2, and be sure to have this arrow to denote that this arrow goes all the way to -infinity, because those are all the numbers that are less than -2. Now, what about at the endpoint -2? So in this case, we're going to put parentheses. All right, let's shade this. Shade. So sometimes, well, depending on what you were doing on my MATLAB, you are just going to be you're going to see this solid line, highlighting all the values that are less than -2. And to avoid confusions, this is there's a negative sign in here. All right. Okay. Sometimes another way to show this is by shading, actually, which is what we did here. The other way, and just real quick, instead of using the parentheses, okay, so I'm gonna go to, okay, here is our 0, and this is our -2. They put an open bubble, an open circle, and then they go like this. So either the parentheses or the open bubble, any of those work. So depending on what you're doing, depending on or the different textbook that you read, or maybe my MATLAB on the homework, you will see the parentheses, or you may see the open bubble at -2, of course. Okay, so now how are we going to use interval notation? So when it comes to using interval notation, the way we write this, we write the smallest number first, followed by a comma, and then the largest value. So in this case, well, I think the easiest one to see is the largest value, the number 2. And the smallest, well, look at the arrow here. Look at that arrow there, so that denotes it's going to -infinity. All right, and in both cases, we use parentheses around those two. All right, let's do the next example. So interval notation for letter B. This denotes the set of all real numbers greater than, or equal three. Be careful. See the difference between these two examples, A and B? Well, example A only had the less than. Alright, this one has the greater than, but also has the equal. So in this case, that's going to make a huge difference when it comes to draw this number lines, or either this way. So we're going to go to the number 3. And I'm going to place a mark there, number 3. And then look at the direction of this inequality symbol. Again, you can think of this as being an arrow here. Now the arrow points towards the right. What is that going to mean? Well, that means that we are going to shade all the numbers that are greater than, or in this case equal to 3. Okay, so I'm going to go like this. Solid line towards the right. But well, of course, we're not going to go and count all the way to infinity. Well, this is just it's enough to just have this arrow representing that infinity tendency there. Now, as opposed to the previous example, well, we used the parentheses in letter A, but in this case, because it's also equal, we are going to use the bracket. Okay, and then from there, typically this is enough. In some cases, they might ask to shade using a highlighter or something. The other way to denote this one, well, so over here we use an open bubble to indicate that we do not touch the negative 2. Over here we are going to use, so this is our 0 here, this is 1, 2, 3. We are going to use a full bubble as opposed to an open bubble, and then shade towards the right of this. Now, looking from the picture, we're going to use interval notation for this given set. Okay, so the lowest end point, in this case, the set starts at the number positive 3 and goes all the way to positive infinity. The infinity symbol always has the parentheses. It never has the bracket, and in this case, instead of using parentheses, because we have the equal symbol here, we use brackets. Okay, so that's final answer for this exercise. Letter C, it's a little bit tricky. You need to be very, very careful. Okay, what are we going to do here? Well, reverse, or rather rewrite by reversing. Okay, rewrite by reversing. So I'm going to write it over here. So what are we going to reverse? Well, everything here. And why do we do that? Because this is not correct. Well, I mean, it's still logically correct, but it doesn't make too much sense when reading it. Here, for example, we call for a number x that is greater than or equal to 3, right? But when we read it this way, negative 4 is greater than x, well, we're comparing the number 4 with something that we are not sure what it is. All right, so that's why we need to reverse the inequality, and we do that by, well, open the curly braces, x such that, so I'm going to reverse the negative 4 where the x is and the x where the negative 4 is. So x and negative 4. But when we do that, be sure to reverse the inequality sign in the opposite direction. All right, so let's write that as a note. Reverse the inequality sign. Alright, so now what are we reading this? So in this case, well, let's interpret this guy in words. This means this guy, this set, is the set of all numbers, of all real numbers, less than or equal to -4. Alright? So what are we going to do here in this case? Well, so we're going to look for the number -4. Okay? Because in this case it also has the inclusive, the equal. It's going to be bracket this time. And again, look at the direction of the arrow. You can think of this as an arrow. It's pointing towards the left. So we are going to shade to the left of -4. Alright? And that's how we describe the set in graphical form. Of course, grab your highlighter. You might want to do this. Maybe not. Using interval notation, well, what is the smallest number in the set? Well, the arrow indicates that -infinity is the smallest number and the largest value in the set is -4. Be sure to have brackets around the -4 and parentheses around the -infinity symbol. Alright, let's look at another example, a very interesting one. Well, what do we have? X such that -3 less than or equal to 3 less than 4. Well, that's not the correct way to read it. When you have a compound inequality such like this, the way we read this is X such that X is greater than or equal to 3 and less than -4. Okay, so let's write this in words. So this is the set of all real numbers that are greater than or equal -3 or and less, strictly less. Notice the inequality sign that we have here. It has only a less than, not a less than or equal, and just less than 4. Alright, now so let's locate those two numbers. In this case, this set of numbers does not involve infinities at all. So in this case, well, this is the lower -3 and this is the upper, the number 4. So what are we going to do? Well, because for the lower endpoint, -3 rather, the inequality has that less than or equal, so we are going to have brackets. And for the upper endpoint, we are going to have parentheses. Okay, so we are going to shade this using our highlighter or whatever you prefer. So an alternative way to graph this one, well, is by having a solid line at -3 and an open, a solid ball, a solid point, and an open hole for the number 4. And that's how we shade this. All right. So using interval notation, well, this is I guess this is very straightforward, unlike the other ones that involve infinity. Why is it more straightforward? Well, because here you have pretty much the lower endpoint, the upper endpoint. Okay, so using interval notation, well, notice this graph is close to where interval notation is. This is not interval notation. This is just an alternative way to express the graphing, the graphical notation of this set. So using interval notation here, lower endpoint -3, a comma, upper endpoint 4, brackets for the lower endpoint, parentheses for the upper endpoint. All right. Now let's move on to the next page. What do we have for the next page? Well, solving linear inequalities. Well, how are we going to solve linear inequalities? Well, it is going to be exactly the same principle as if we were solving linear equations. So what do I mean by that? Well, so every time, for example, when we have an equation, whatever operation we do on one side of the equation, we're supposed to do it on the other side of the equations. And you might remember that from the previous section, from section 2.1, when we solved equations. Whatever you do on one side, you do it on the other side. You add one number on one side, you make sure to add it on the other side as well. Multiply, divide both sides by the same number. So the only difference here is, and I have it here as a remark, is that every time we multiply or divide both sides of an inequality by a negative number, the inequality sign must be reversed. And the reason for which you do that, well, if you learned it before and you never knew what was the reason, well, let me give you a few examples to show you why do we do that. Well, so for example, what if I have 3x equals 6? Well, to solve this equation, well, this is equivalent to say divide both sides by 3, boom, divide, x equals to 2. Okay, that's one example in which as we carry all the steps, we are still preserving the logic of the sentence. For example, if I have, well, 5 equals 5, that I think that's clear, 5 equals 5. If I add 1 to one side, I have to add it to the other side as well. 5 plus 1 is 5, is 6. 5 plus 1 is also 6, so we still have the property that 6 is equal to 6. Okay. Also, when we have equations, sometimes you're solving an equation, and depending on how you arrange your sides or how you manage your sides of the equation, you end up with something like 2 equals x. This is exactly the same as x equals 2. It doesn't matter how you read it. 2 equals x, x equals 2. Okay? Now, what about with inequalities, for example? Well, let's put something that is a true statement, actually. For example, what about between 4 and 6? Which one is larger? Well, if you look at these two numbers, the number 6 is larger, so the corresponding inequality sign would be 4 less than 6. Okay? What happens, for example, if I add 2 to both sides? Okay, I'm going to get 4 plus 2 equals to 6, and 6 plus 2 equals to 8. Does the inequality sign still hold true? Of course, because 6 is still less than 8. With the same example, 4 less than 6. What if I multiply both sides by, let's say, by 3? If I do it on one side, then I have to do it on the other side as well. So let's do the operations. 3 times 4, which is 12, and 6 times 3, which is 18. Does the inequality still hold through? Of course, because 12 is indeed a number that is less than 18. Okay, so hopefully up to this point, I mean, nothing new. You have seen all of this before. But what about when it comes to multiplying both sides of an inequality by a negative number? And I'm going to take the same example. 4 less than 6. Okay, 4 less than 6. If I multiply one side of the inequality, okay, just to make this simple, I'm going to multiply by negative 1. Alright, I'm going to multiply both sides by negative 1. What do I get when I multiply negative 1 times 4? I get, of course, negative 4. If you thought it was negative 4, that's correct. What do we get when we multiply 6 times negative 1? I get negative 6. Does this inequality still hold through? Is it true that negative 4 is less than negative 6? Well, not in this case. In this case, we cannot keep the same inequality sign. Instead, we have to reverse, because the number negative 4 is greater than negative 6, and of course, okay, this is 0, 1, 2, 3, 4, 5, 6, 7, okay, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Between negative 4 and negative 6, which one is bigger? Of course, 4, right? This is bigger. This is smaller. All right? So that's why we reverse the inequality sign when we multiply both sides of an inequality by a negative number. Hopefully this helps, because we're going to be doing a bunch of this on the following examples. Alright, so now let's move on and solve inequalities as well. Solve inequalities, graph the solution set on the real number line, and then show the solution set using interval notation. Well, this one is going to be very short equation. So need to isolate the x, and we get that by adding 2 to both sides, and x less than 7. All right, so that's the solution to the inequality. Well, this is telling us to graph all the numbers that are less than 7. So the number 7 is right here, and because it's only less than, we're going to go and use parentheses, but less is to the left all the way to infinity. All right, all the way to infinity. Now, expressing this using interval notation, well, this is what we do. Solution set the smallest number, which is solution set using set notation, we go x such that x less than 7. That's the set builder notation, like the ones that we work on the previous page and in this next page. I mean, in this the other way to express this is negative infinity to 7. And by the way, parentheses for both cases, because parentheses over here and infinity or negative infinity, none of them ever take the bracket. They always take the parentheses. Another simpler one, well, for x greater than negative 20. Alright, so all we have to do here is on both sides divide by 4. So x greater than or equal negative 5. So that's the solution. So solution set using set notation, x such that, and just copy what you obtained from the solution of the inequality. Now, what does that represent? Well, we're going to go to -5, which is right here. But in this case, greater than -5, that it means towards the right. And in this case, by means of brackets, because we have the greater than or equal. If we didn't have this equal part, it would have been parentheses, just like the previous case, like letter A. So let's shade towards the right. All right, and just shade. You can use a highlighter again, or when you see it on MyMATLAB, maybe you will see the solid shading, just the shading just as a solid line. That's what I meant. Alright, let's look at something a little bit more interesting. Okay, well, so that looks more like the equation that we solved. So for a minute, you might want to forget that you are doing inequalities and treat this like an equation. However, carry out the inequality sign all the time. Well, in this case, for the left-hand side of the equation, we have everything simplified, so there's nothing we can do about it. However, on the right-hand side, look at the parentheses here. That means that we are going to use the distributive property. So let's distribute that and get 3x plus 2 less than 4x minus 8. Alright, and then from here, let's move the x's to the left and the numbers to the right. In this case, well, you might want to do it this way. Be sure to have all x's on the left hand side and all the pure numbers on the right hand side. Alright, so I'm going to subtract 4x on both sides. That's going to cancel the 4x's here and leave me with a -8 on the right hand side, and here 3x minus 4x is going to give us -x. Careful with signs. We are almost one step away to oh, I forgot the +2 here. The +2, I forgot to drop that. So let me clean it up so it looks better. Okay, so +2 -x. So now we are going to subtract 2 to both sides. That's going to give us cancel first, and that's a -x less than -10. And last but not least, as a last step right here, we are going to divide both sides by -1. But be careful, what do we do when we divide or multiply both sides of an inequality by a negative number? Well, if your thought is to change the inequality sign, then you are correct. So negative over negative is positive x. Change the inequality sign's direction, and negative over negative is positive 10. Alright. So here in this example, we are applying this remark that we have at the top of the page, that every time we multiply or divide both sides of an inequality by a negative number, then the inequality sign must be reversed. Alright, so this is our final answer for the inequality solving process only. Okay, so I'm going to change these numbers right here because I'm not going to have enough numbers. So I'm going to make this 0, 2, 4, 6, 8, 10, 12, 14, 16. Just so it works for us. Okay, for our purpose, because in this case, well, all the numbers that are greater than, that means to the right of 10. Alright, let's see, just shade and we're good to go. Now solution set. Using set builder notation, x such that x greater than 10. That is the same sentence, the same statement that we got from the solution of the inequality. And for interval notation, the smallest number, which is the number 10, and positive infinity, which is denoted by this arrow, denoting that it's going forever, right? And in this case, parentheses for both. And by the way, I forgot the interval notation for the previous one. So in this case, greater than negative or greater than or equal -5. That's from -5 and on to positive infinity. All right, let's look at the next example, letter D. Well, for letter D, we have the quotient between -3x plus 10 quantity over 2 less than -1. Okay, so the first thing you see is the fractions, and yes, let's clear the fractions first. Just the same way we learned on section 2.1 last week. What do? Multiply by the LCD, which in this case is 2. So over here, you might want to just cancel these 2's. Don't feel tempted to distribute this because that's not the correct way. So here we are multiplying both sides to just cancel, and we bring down what we are left over with, which is -3x plus 10 less than -1. That times 2, that's a -2. From there, well, let's subtract 10 to get -3x less than -12, and divide both sides by -3 to divide out these -3's, and x less than actually 4. All right, did I make a mistake here? Yes. Did you notice I made a mistake? What was I supposed to do? And in this case, I was supposed to reverse the inequality sign, and that's because we divided by a negative number on both sides of the inequality. Again, we are applying the remark that we have here, that every time we multiply or divide both sides of an inequality by a negative number, the inequality sign must be reversed. Okay, so end of the solution, end of the inequality, and then from here, solution set using set notation x such that x greater than 4, and using interval notation, well, let's do the graph first. So greater than 4, like this pretty much, using parentheses because it's only greater than, there's no equal part. Okay, and it's going to be from 4 all the way to infinity. All right, let's move on to the next and last page of this section. Well, the examples are now starting to get a little bit more interesting. Well, like starting with this one, letter E. All right, so 2/3 plus 6/7 less than x over 21. Well, what do you feel about fractions? You don't like fractions, right? So that's why we call you fractions, right? So no fractions. Well, let's clear up these fractions. Again, what was the process to get rid of the fractions? Here, multiply both sides of the inequality by the least common denominator. Okay, in this case, the least common denominator, again, by definition, is the number that is going to divide out but all these numbers, the number 3, the number 7, and the number 21. And in this case, the number that works out nicely is the number 21. Okay, so let's see, what are we going to do here? Well, let's distribute the 21. The 21, keep in mind, is going to multiply only with the numerator of each fraction. Okay, so what am I going to get? Well, I'm going to write 2/3 plus 6 over 7 less than or equal x over 21. Notice the space I'm leaving here. That's the space I'm going to do for the distribution here. Alright, this we can just divide them out really easy. That's going to leave us with x. And then over here, of course, I know what you might be thinking. Multiply 21 times 2 to get a bigger number, and then do a division. Well, that's not that bad to perform. However, the second term right here, 21 times 6, huge number. Let's make it more complicated. Well, so what are we going to do here is we are going to simplify 21 over 3, which is 7 times 2, and then 21 over 7, which is 3, and in this case, well, 7 times 2 is 14, plus 3 times 6, which is 18. Okay, and then from here, this is less than or equal x. Well, again, keep in mind that the variable is not meant to be on the right hand side. That's why I wrote this exercise in this form and this way. So, well, we're gonna get there. Here all we need is to simplify 14 plus 18, that's 32. Less than or equal x. What do we need to do here? Reverse. Okay, let's do the reversing operation. X 32. However, need to reverse the inequality sign as well. Alright, so in this case we are not going to have a nice number line the same way we do it. So in this case we are going to do it ourselves. So I'm going to have the number 32. Okay, a solid bubble at the number 32. Why is it going to be a solid one? Well, because we have the greater than or equal. Because it's greater than or equal, then it's going to be this way. Okay, so we shade it this way. Alright, and you can think of the 0 being somewhere here. It doesn't have to be perfect. I mean, as long as the number sense makes sense. Okay, so that's one way. The other way is to, instead of the full bubble, we can use the bracket. And also, likewise, starts at 32. So either way, solid bubble or bracket here. All right. Oh, it was kind of slopey, this bracket. All right, so you get the meaning. You get the picture here. Okay, so solution set. Solution set using using set builder notation x such that the solution you got here, just copy and paste here. And using interval notation, bracket 32, the lowest, infinity, the largest. All right. So solution set using both notations. All right, let's look at another example. Letter F. All right, so yes, we have fractions here. We have to deal with them. Well, the least common denominator between 7 and 14 is 14. All right, 14. So in this case, again, the equation looks, the inequality looks really big. It's going to make you think that you will have to distribute the 14 with the 2x and the 1 and the 12. Be careful about doing that because this 14 is multiplying. So what it's going to do here is we are going to do 14 over 7. That's a 2 times 2x plus 4 plus 12, rather, not 14. And over here, if you will, you might want to just divide these two out. That's going to leave us with the 3 that was in the numerator. And keep the inequality sign. The reason we keep the inequality sign is because we haven't multiplied both sides of the inequality by a negative number yet. All right? I don't think we're going to do this in this case. Well, who knows? So the next step here, well, we see parentheses. We use the distributive property, same here. And 4x plus 24 greater than 3x minus 3. And then from here, it's just moving terms around. I'm going to move the 24 to the right hand side by subtracting 24 to both sides. That's going to get this canceled. And negative 3 minus 24, that's negative 27. All right. And the next and final step here is to subtract 3x. So x is greater than negative 27. So that's the solution to this inequality. Using the graph, well, so using the bubble, the solid bubble or the open bubble, in this case, the greater than, notice, doesn't have the equal. So I'm going to have only an open bubble, an open circle. And, well, it's greater than. I'm going to shade towards the right of it. All right. And using the parentheses, well, we did the same negative 27 all the way to infinity. So now it's time to write this using set notation. All right. X such that x is greater than negative 27. Okay. So using interval notation, negative 27 all the way to infinity. Okay, both of them have parentheses. Okay, look at the inequality sign, how it is consistent or congruent with the parentheses or the open bubble. Okay, let's do one more. This is the last one, the last example of this exercise, and we are good to go. All right, we're good to go after solving this one. All right, so we see a lot of parentheses here and there. Well, what is that going to tell us to do? All right, so distribute. That's going to give us 5x minus 5 minus 2x plus 3 greater than or equal to x minus 3 times x, which is 3x, and then minus 3 times 1, which is negative 3. All right. Okay, from here we have a bunch of terms in here. So let's combine like terms. So I'm going to combine numbers with numbers, x's with x's, x's with x's on each individual side. All right. So 5x minus 2x, that's going to give us 3x. Negative 5 plus 3, that's going to give us negative 2. Okay. Greater than or equal to x minus 3x, that's going to give us negative x, and then minus 3. From here, the last step right here is to just move terms around by adding x to both sides. Cancel, cancel. and 3x plus x, that's 4x, minus 2, and equal, like greater than or equal negative 3. So let's add to the both sides of the equation. And negative 3 plus 2 equals negative 1. Finally, divide both sides by 4 to get this 4's canceled, and x is greater than or equal negative 1/4. Alright, so if 0 is here, well, 1/4 could be, it's always above. Well, never mind, is it negative or positive? It's positive. Let's see, where's my eraser here? So this is negative 1/4, and then towards the right. The other option is full bubble at 1/4, and then towards the right. Now let's write down the solution set. Using set notation or set builder notation, x greater than or equal negative, x such that x is greater than or equal to negative 1/4, and 1/4 all the way to infinity. Okay, and if you look at this, you might be thinking, well, I did a couple of mistakes. Of course, number one, I forgot the minus here, and the other mistake I did is the wrong grouping sign. In this case, the wrong grouping symbol. The right grouping symbol should have been bracket, not parentheses, because we have the inequality sign. And this is a good place to quit for this topic. I'll see you on the next video.